Right now, there's a war happening, not with bullets or tanks, but with rocks. 17 specific elements buried in the earth have become the most strategically important materials on the planet, and one country controls almost all of them. In 2025, China didn't just restrict exports of these materials, they weaponized them. Prices shot up 6 times overnight. European factories shut down. The U.S. scrambled for alternatives. But here's the twist. These elements aren't even that rare. The real story is far more complex, and it's reshaping global power as we speak. This is a hidden war for rare earth elements, and by the end of this video, you'll understand why the future of everything, from electric cars to wind turbines to your smartphone, depends on who controls these materials. So, what exactly are rare earth elements? Despite the name, they're not actually rare. There are massive deposits all over the world, over 90 million tons of proven reserves. Rare earth elements, or REEs, are a group of 17 chemical elements. 15 of them are called lanthanides, plus scandium and yttrium. Their names sound like they're from a sci-fi movie. Neodymium, praseodymium, dysprosium, terbium. What makes them special isn't their scarcity. It's their atomic structure. They have partially filled 4f electron shells, which gives them absolutely insane magnetic, luminescent, and catalytic properties that you just can't get from other materials. Let me give you an example. A neodymium magnet can lift over 1,000 times its own weight. Regular magnets? Maybe 10 to 20 times. This isn't just a neat party trick. This difference is what makes electric vehicles and wind turbines actually viable. Inside every electric vehicle, there's a traction motor. At the heart of that motor are neodymium iron-boron magnets. These magnets provide the high torque density needed for rapid acceleration while keeping the motor compact and lightweight. Without them, your EV would either be massive, slow, or have terrible range. For wind energy, particularly offshore, rare earth magnets enable direct drive generators, no gearbox needed. A single large offshore turbine can contain hundreds of kilograms of rare earth magnets. These turbines need to survive brutal ocean conditions for 20-plus years with minimal maintenance. Rare earth magnets make that possible. Beyond magnets, rare earths are everywhere in the green energy transition. They're in the phosphors that make LED lights energy efficient. They're in the glass coatings on solar panels that boost efficiency. They're in catalytic converters that clean exhaust. And it's not just green tech. The military depends on rare earths for precision-guided missiles, sonar systems, and jet engine coatings. Which brings us to the real problem. If rare earths exist all over the world, why does one country dominate? As of 2024, China controlled 60% of global rare earth mining. But here's the kicker. They controlled 90% of global refining and processing. Mining the rocks is one thing. Turning them into pure, usable metals is something else entirely. This didn't happen by accident. For decades, China pursued a deliberate industrial policy. They leveraged their abundant reserves, accepted lower profit margins, and most importantly, they were willing to bear the environmental costs that Western countries weren't. Through the 1990s and 2000s, Chinese rare earth production flooded global markets with cheap supply. Western mines couldn't compete and shut down. Refining facilities closed. Expertise disappeared. By 2010, the world had become almost completely dependent on China. Then came the wake-up call. In 2010, after a territorial dispute with Japan, China temporarily halted rare earth exports to Japan. Prices exploded overnight. Japanese manufacturers panicked. The world suddenly realized they'd handed complete control of a critical resource to a single country. But that was just a preview. In 2025, the situation went from concerning to critical. In response to U.S. tariffs and security restrictions, China implemented 2 waves of export controls. Wave 1, April 4, 2025. China restricted exports of 7 heavy rare earths essential for data equipment, motors, and wind turbines. These are the elements that make high-performance magnets work at elevated temperatures: dysprosium and terbium. Wave 2, October 9, 2025. China expanded restrictions to 5 additional elements plus, and this is crucial, processing equipment and technical expertise. This second wave had extraterritorial reach. China claimed the right to control foreign-made products that use Chinese rare earth inputs or technology, essentially saying, even if you process it elsewhere, if it came from us or used our methods, we control it. Here's the uncomfortable truth about the green energy transition. It's built on a foundation of environmental devastation. Extracting 1 ton of rare earth elements produces up to 2,000 tons of toxic waste. We're talking heavy metals, acidic wastewater, and radioactive byproducts like thorium and uranium. Think about that ratio. 1 ton of useful material, 2,000 tons of poison. This waste gets stored in unlined lagoons or massive tailings dams that leak into watersheds and agricultural lands. It's a ticking environmental time bomb. Some operations use a method called in situ leaching. Instead of digging massive pits, they inject strong acids directly into the earth to dissolve the minerals underground. Sounds cleaner, right? Wrong. Those acids contaminate groundwater permanently, and unlike an open pit you can eventually remediate, underground contamination is nearly impossible to clean up. The refining process isn't any better. It requires extensive chemical treatments that pump sulfur dioxide and particulate matter into the air, degrading local air quality and causing long-term health problems for anyone living nearby. But nowhere is this contradiction more stark than in Myanmar. This is where the human cost of our clean energy future becomes impossible to ignore. Myanmar supplies approximately 60% of the world's dysprosium and terbium, the heavy rare earths that make high-performance magnets actually work. In 2025, satellite analysis identified over 400 mining sites in Kachin State alone. Water samples from the Kak River, a tributary of the Mekong, show a chemical fingerprint of heavy metals directly linked to rare earth mining. This isn't just local pollution. The Mekong provides water, fish, and irrigation for tens of millions of people downstream. The vulnerability is obvious. The environmental cost is staggering, so the race is on to develop technologies that don't need rare earths at all. And it's actually happening faster than most people realize. BMW has become a leader in this shift with their 5th-generation eDrive system. Instead of rare earth permanent magnets, they use something called an externally excited synchronous motor, EESM for short. Here's how it works. Traditional rare earth motors use permanent magnets on the rotor. The magnetic field is always there, always pulling. EESM motors replace those permanent magnets with electromagnets. They feed electricity into the rotor windings through slip rings. The result, efficiency over 95% in normal driving conditions. And at highway speeds, they actually outperform rare earth motors because they eliminate drag losses from permanent magnetic fields. BMW has already put this technology into series production. The i4, iXS, and i7 all use zero rare earth motors. Let me show you how these technologies stack up in 2025. Rare earth. PMSM, 95% efficient, high power density, industry standard, but extreme supply risk. EESM, BMW Renault, NIHA, 90% efficient, zero rare earths, in series production, slightly bulkier, but especially good at highway speeds. Induction, Tesla, Audi, 88-92% efficient, zero rare earths, mature technology, rugged and lower cost, but generates more heat. Ferrite-based, Ola Tesla, 85-91% efficient, zero rare earths. Commercial pilot stage, 30-60% cheaper, but lower power density. There's another way to break dependence on primary mining, recycling. And in 2025, rare earth recycling is exploding. The rare earth recycling market is valued at about $300 million in 2025, but it's projected to grow at 25% annually through 2032, reaching $1.4 billion. By 2035, recycled rare earths could exceed 810% of total global supply. Here's why recycling makes so much sense. End-of-life products like hard drives and EV motors contain way more concentrated rare earths than raw ore. A breakthrough technology called hydrogen processing of magnetic scrap, HPMS, uses hydrogen gas to break down magnets into powder. This allows separation of coatings and other materials without intensive energy or harsh chemicals. Pilot plants using HPMS launched in North America and Europe in 2024-2025. Major automakers like Stellantis and Tesla have committed to using recycled magnet content in future models. The challenge isn't the technology, it's the logistics. You need to collect millions of old hard drives, used electric motors, and end-of-life vehicles. You need to sort them, transport them, process them at scale. But that infrastructure is being built right now. And as more EVs reach end of life over the next decade, there will be a tsunami of recyclable rare earth magnets available. The circular economy for rare earths isn't some distant dream. It's happening. And it's one of the most promising paths to reducing dependence on conflict minerals. The 2025 export restrictions were a wake-up call. Governments worldwide are scrambling to rebuild their rare earth supply chains. But this time, they're doing it strategically. The G7 Critical Minerals Action Plan, endorsed by Australia, India, and South Korea, focuses on developing standards-based markets and coordinated stockpiling. The goal? Never again be held hostage by a single supplier. The European Union adopted its Critical Raw Materials Act in 2025, with risk monitoring and support for extraction and refining projects within member states. By March 2025, they'd already selected projects in France, Italy, Poland, and Sweden, focusing on rare earths. The path forward requires hitting on all cylinders. 1. Diversify mining to reduce geographic concentration. 2. Invest in refining to break the processing bottleneck. 3. Accelerate rare earth-free motor adoption and alternative materials. 4. Scale up recycling and implement strict environmental standards. Under the IEA's projections, rare earth demand will increase 50 to 60% by 2040 under current policies. Under net zero scenarios, it's even higher. The question isn't whether we'll need more rare earths. The question is whether we can build a supply chain that's secure, sustainable, and doesn't require humanitarian and environmental catastrophes. China weaponized that control in 2025, and the world is still reeling. But the era of passive dependence is ending. From BMW's rare earth-free motors to Niron's iron nitride magnets, from EU stockpiling to recycling breakthroughs, The fight back is real. By 2030, the rare earth landscape will look completely different. More diversified sources, more recycling, more rare earth-free technologies. But getting there requires massive investment and political will. The hidden war for rare earth elements isn't really about rocks. It's about who controls the future. And for the first time in decades, that future is up for grabs. The question is, who's going to win? If you like this video, subscribe to the channel so you won't miss any upcoming ones. Thanks for watching, and I will see you in the next one.